Okay, so here we got it. So today we are going to be doing the Hot Wheels lab activity. And you are going to be in this lab investigating how the slope of the ramp affects the speed and acceleration of a toy car. What are dog? I put on lotion, I think.
Lesson 3. Have an 11 one.
What was that? Let's see who's saying that. All right. So, everybody's got their mic on. Not exactly sure who right now, but I can hear you. Okay, so anyway, in this lab activity today, our Hot Wheels lab activity, you're going to investigate how the slope of a ramp affects the speed and acceleration of a toy car rolling down the ramp. And you are going to be able to apply Newton's laws to the car. So that is what we are doing today. That is what our the purpose of our lab is. And just to talk to you a moment about some things that were recently due. You had science of NFL. Last time we got together, our last class, which was Friday. Yeah, it was Friday. We looked at some videos about football and how they apply to Newton's laws of motion. And there was a short little worksheet that was due yesterday, Monday, yesterday by 11 a.m. So hopefully you got that in. And we also had a couple other things due last week. Actually, just one other thing. Newton's laws of motion notes were last Wednesday's class, and those were due, I think those were also due on Friday, as a matter of fact. So I forgot to write that there, but the science of NFL and the Newton's laws of motion notes were due recently. So you got those in. If not, you want to make sure that you do so. And everybody's got their mic on. Let me see who it is, because I thought they were all muted. Okay, so let's mute you guys. All right, and one more. Okay, there we go. Now, peace and quiet. I'm going to miss that feature when I get back into the classroom, guys. Okay, so anyway, there will be some things due this week. And as per some new, some changes that came out this week to kind of streamline when things are due, since that seems to be a difficult thing to navigate from what I'm hearing is when everything is due. So right now they're telling us everything is due on Friday. So both, you're gonna have two labs this week, today and Thursday. And there is a worksheet that goes along with both of them. Participating in the labs, doing them alongside me, and recreating the labs with me, I think is gonna be a lot of fun, and I hope you do it with me, but it is optional. What is not optional is the worksheet, or what I'm calling the lab activity. That is not optional. And that is a worksheet that is your lab report, basically. So I didn't call it a lab report, but that's essentially what it is. And you should be getting that out right now. That, again, is not optional, but participating in the lab with me, building this ramp that I have right here. Making your ramp and racing your Hot Wheels cars are optional, but participating, or I should say filling out the lab sheet, is not optional. And it is due, both of them will be due this Friday by 11 a.m. Okay, so this is what today's lab activity or lab report looks like, and you should have that handy along with a calculator. And see. Pardon me, I guess I didn't pull that up, but I shall. Okay, so this should be it right here. Okay, so there's 3 pages to this, but the first page that we're looking at right here is about the lab activity, our purpose, our hypothesis, what materials we're going to need to pull this off, and our step-by-step procedure. So we're going to go over this here in a second. The second page of this document has the data tables. There's 3 of them. You do have to fill these out. So this is where there won't be anything that you need to write on page 1. But on page 2, you're going to be filling in these, this data table 1, data table 2. The difference between these two is the slope of the ramp. So I'm going to use 10 books and make a steeper slope in the first round, first 3 trials of this experiment. And then data table 2 is where we're going to decrease the slope by half and take out 5 books. And then we're going to race the car down the ramp again 3 more times and put our data in there. If you're participating alongside me today, you can put your own data in here. And if you are not participating in, or if you want to use my data, I'm going to be doing it today, and we're going to collect this data. Where it says speed here on these 2 data tables, this is where you're going to have to calculate speed, distance versus time, or I'm sorry, distance divided by time. And so that's why you need a calculator today. And then we're going to calculate acceleration, and I've given you step-by-step on how to do that. Hopefully we will do that together today, but if we run out of time, you'll have all of your data and you'll be able to do this. And then we have the third and final page of this document here. Seatbelts save lives is another little tiny experiment we're going to do after, where we're going to put a little clay person that we make out of Play-Doh or clay. And so if you have some Play-Doh or clay, you can have that handy. And then we have some questions. I think there's 7. Yes, 7 questions right here that you're going to answer. This is what you'll be doing on your own. If we have time, we'll go through them a little bit together, but likely this is your homework. And then, by Friday of this week, you should have turned in the second and third page of this document. So the data table that we'll collect today, your calculations, and then the answers to your questions. All right, so does anybody have any questions so far? How are we doing? Okay. Looking good. There's 19 of you here today. That's not bad. I think that's one of our best turnouts. So I was saying, if you joined us a little bit later, that I'm really glad you joined us today, because doing these labs I'm going to do them live here for you. And if you don't come to our Zoom class, or at least watch it on video later, it would be really hard for you to do this assignment. Which is Hot Wheels Lab Activity. And that was the paper that I was just bringing up, that I'm actually going to bring up again, because I want us to look at our setup, what materials we need, in case you would like to do this along with us. So kind of a little diagram here showing a ramp that we're going to build. And how you build this ramp is really up to you. How I have my ramp set up is I have books here set up. Let's see, we've got 10. I've got 10 textbooks, etc. up here. And then I just have a piece of a board, a particle board from, actually composite board thing from my porch. And then at the end of my ramp here, I have another book. And let's see, can you see that? Down here, where this book is going to stop my car. Then you're going to want a measuring tool so that you can measure 1 meter. So you are going to, I have a meter stick right here. Does anybody know how many feet are in a meter? Anybody know this? because you are most familiar with feet since you live in the United States. Yes, that's right, Bryson. It is, well, almost. So Bryson says 3 feet. You're really close. What 3 feet is actually is 1 yard. This is a yardstick. Notice that the yardstick is a little bit shorter than the meter stick by 3 inches. So 3 more inches on this ruler, and you have a meter. So basically, and Trevor, I saw your message about not having a car. I'm going to address that next. So we're going to measure 1 meter for our car's distance to travel. So if you have a meter stick, fabulous. 3.3 feet is a meter stick. If you have a yardstick, you're going to do 1 yardstick plus 3 inches, which you could do. 1 yard is 3 feet. Yeah. And so there's inches on your yardstick, so you can measure that out. If you have a ruler only, then you would want 3 of these. So 1 ruler is 1 foot. So 3 of these would be equivalent to a yardstick, and then you would need 3 inches more. Okay, so 3.3 feet, which is just about 40 inches, 39.37, something like that. Okay, so that's how you're going to measure. Now, if you do not have a car, then, and I'm going to use, I think, this car here, got a bunch of Matchbox cars. You could use something else that rolls, so like a marble or a ball, like a small ball. Maybe you have another toy that happens to have wheels. And so anything that rolls would be just fine. I'm going to use this card rather than, I was thinking about letting you guys choose which car rolls down the ramp. And I suppose we could do that. And I have a few more. Okay, oh, Toby's coming in. Let me get him in here. Okay, all right. Toby makes 20. Okay. Good morning, Toby. Glad you could join us. Okay, let's see. What do you guys got to say for me, to me? Oh, yeah, I see Trevor calculated how many feet are in a meter, right? 3.28084. Very precise, Trevor, thanks. All right, so again, we're setting up our ramp here. Ouch. Pull this down a little bit. And we've got 10 books. We've got a board or something, cardboard might work, anything you can use to make a ramp, maybe a binder. And then we talked about measuring 1 meter that the car is going to travel. So the car is right here. I've measured, oops, that's a yardstick, meter stick, 1 meter, and then you want another book or something at the bottom of your ramp here to stop your car. And then set aside, you have a clay or Play-Doh person, maybe, for our seatbelt save lives part. I am honoring my hominals today, my howler monkeys in my purple and yellow colors today. All right, so that's how you set up. And those of you just joining us, again, participating in the lab, actually setting up the lab and collecting your own data alongside me is optional. If you are doing it and you would like to show your video of you doing it too, like we can turn on your video if you behave yourselves and don't conduct yourself in a immature way. We can have you up on the screen too if you would like, participating along with us. That's not optional, but I should say that is optional, but filling out your lab report paper, that is not optional. Everybody does have to do that, okay? All right, so we're gonna go ahead and get started. Oh, I did have just a short little video that I was going to play. It's just a few seconds of a group of people that had a whole 500 Matchbox cars that they sent down a a ramp. So let me see, where's my, sorry, looking for my share screen here. Okay, there. Yeah, right here. And hopefully we've got some good sound. It doesn't really matter if there's not sound, but I just hope it doesn't buffer. Okay, let's check this out.
25 cars, we're about to send them down. 3, 2, 1. Raise it up, go! All right, let's go down there and see one. Check it out.
All right,
Here we go.
so,
oh, that's one of my.
so I thought that was kind of fun. I guess there were 500 cars total. They did them 25 at a time. Right. Well, we're going to go ahead and start our lab. So looking at our document here, our purpose is to investigate how the steepness of the slope affects the speed and acceleration of a toy car rolling down a ramp, and to be able to apply Newton's laws of motion to the motion of the car. So the hypothesis I've already set for us is that if we decrease the slope of the ramp, the toy car will decrease in speed, which is negative acceleration, slowing down, because the force of gravity acting on the car will be decreased. So the materials, one ramp, a meter stick or other distance measuring tool, a timer stopwatch, 11 or more books, and a Hot Wheel car or other object that rolls. And then I forgot to put on there Play-Doh or clay for our little person. Okay, which we don't need until the second part of this. Okay, so we have set up the ramp. We are going to have our toy car or whatever object that rolls at the top of our ramp, and we are going to be having our timer ready as well. And so right as we release the car at the top of the ramp, we are going to hit start on our timer, and then we're going to hit stop on our timer as soon as the car hits the book 1 meter away. So we're going to be timing the amount of seconds it takes for the car to go from the top of the ramp to the bottom of the ramp 1 meter away. All right, so get your timers ready. Get your timers ready and your car ready, okay? So raise your hand if you think I should race this car. Let's see if I can. All right, so we've got, I'll give you just a couple to choose from. Okay, so we got this one. We got this one. So we'll say blue, green, and yellow. All right, raise your hand for green. Is anybody raising their hand? Nobody wants green? Oh, somebody did. All right, Bryson likes that one. All right, how about blue? So Bryson, put your thumb down. All right, John and Toby like that one. And I think that's it. Okay, and yellow. No. All right. Well, I think the blue one won because there was only a few people that voted on that. Okay. It's a little bit smaller than that other one, so hopefully you'll be able to see it okay. All right. Getting the timer ready. And we are going to be writing the time. We're going to do this 3 times, and we are writing our time in the data table number 1. So, and actually while you're at this, you might as well fill in your distance in meters. It's going to be 1 for all 3 trials, actually all 6 trials. So 1, 1, 1, 1, right? Can I fill that in? 1, yeah, 1, 1, 1, And then, these will also be. Okay. And what we're going to be getting our time for right now is going to go in this data table under time. Okay. All right. So got my timer ready. Actually, I don't, but I will. All right. Here it is. And I actually want my stopwatch is what I'm going to use. Okay. All right. So got 1 meter away. Here's our car. And ready, set, go. All right. 0.73. 0.73 seconds. All right. So let's plug that in here. All right. 0.73. Oops, that's kind of a weird thing. There we go. All right. And then let's do it again. Okay. All right. See, I don't even think you guys can see the car here. I'm not sure that you can. Oh, Mr. Wolford's coming. Okay. Welcome. Okay. All right, here we go. Still think we should have used the bigger car. All right, so ready? Trial 2. And go. Okay. All right, so here is our data for that trial, 0.90 seconds. All right, so let's go ahead and fill that in right here. 0.90 seconds. All right, now we got to do it one more time. Okay. All right, ready with your cars, or your ball, or your marble. Okay. All right, trial 3. Ready, set, go. That was a lot faster. Now, of course, this is subject to reflexes and reaction time. So how accurate I am, I'm not exactly sure. But 0.69 is our next and final trial there for the steep slope.
Yeah, I don't think she understands. She just called me, so let me check in with her. The question, though, was that whole closet with all the dead files in it. What do you want us to do with those?
Sorry, I got it. I had to mute Mr. Wolford there. Okay. All right. So 0.69. All right. Now, what you guys are going to do is you need to find your average time, and then we need to calculate speed. So while I am setting up the next slope and decreasing the slope, I want you guys to use your calculators to calculate average time and your speed. So to calculate average time, and I have this on your sheet, this would be, so calculating your speed right here was number 8. You do this by using distance divided by time. All right, our distance is always 1 meter, and then we divide by the time, those times we just got for our data. And then you are going to calculate your average speed for the 3 trials by adding up those 3 speeds and dividing by 3. Okay, so here you would do your 0.73 divided by 1, put your number here, your 0.90 divided by, oh, I'm sorry, I did it, I said the wrong thing. I'm so sorry. I'm glad I caught myself. Sorry, distance divided by time. So 1 divided by 0.73 and 1 divided by 0.90 and 1 divided by 0.69 and put your speeds there. Then you're going to add those 3 speeds up, divide by 3 because there are 3 speeds. That's how you find average. You find your average speed. For your average time right here, you'll add up your 3 times and divide by 3 for your average time. So that's what I'd like you guys to be doing right now. Well, I decrease my slope by taking out 5 books to make the slope half as steep. Okay, so you do your calculations. Don't forget to, if you're setting up to remeasure, make sure you're still 1 meter away. Okay. All right, so let's see how we did on our speed calculations and average time. Where's my calculator? There it is. Okay. All right, so what do we have? Oh, somebody's trying to talk to me. All right, let's see what we got here. Trying to find my chat box. Oh, there it was behind everything. Okay. All right. Okay, nothing of any importance there. All right, going back. So you guys were calculating your speed. All right. Who can tell me what they got for speed for the first speed? Speed number 1, or I should say the speed for trial number 1, which was 1 divided by 0.73. Who's got this? Nobody's raising their hand. I tell you what, I'm not going to just feed you the answers, but if somebody would like to share theirs, we'll put it in. All right, John, thank you. I'll unmute you here. All right, John, what'd you get for your speed for
for my speed, I got 1.37.
Yes, very good. And I like that you rounded. You didn't give me 8 million digits there. You rounded it to the hundreds place. So since somebody gave me an answer there, we'll do that. All right, thank you. So that's 1.37. And what would that, John, what would the units be for that? It is written right there for you. Just
isn't it m/s2?
That would be for acceleration. You would use the exponent squared, but for speed, it's just m/s, which is meters per second. Why?
Oh.
Because our distance was in meters and our time was in seconds. So it's meters per second, and the per means we divided it. So that slash there, m/s means meters per second, or meters divided by seconds. Okay, and so then you guys can do your speeds for trials 2 and 3 and your average speed. Actually, let's get one more thing. Let's get the average speed in here. I'm sorry, our average, yeah, we should probably get our average time and our average speed so we can work on acceleration together. So who found the average time? Excuse me, this was your adding up of your 3 times in seconds and dividing by 3. I'll write it in there if somebody volunteers to give that answer. Otherwise, I'm going to let you guys do it on your own. Okay. All right. No takers. Oh, John's going to. John, do you still have your hand up from last time, or do you want to answer this again?
I'd like to answer this one.
All right. Thank you, John.
So I got 0.773 repeating.
And that sounds right. You were doing so good about the not giving me a whole bunch of units there. You said 0.77 or 73?
Yes, 7.3 repeating.
7.3 repeating. Yep. Let's check that out here. Okay, 0.73 plus 0.90 plus 0.69 divided by 3. Oh, I see the 3's repeating. Okay, 0.77. Yeah, okay, 0.77. We're just going to leave it like that. Okay, and so what do let's go ahead and do our next set of data here for our 3 trials for 5 books now, or half the slope that we used before. So however many books you might have used if you were doing this with me at home, just take out half of those, and we're going to do this again. All right, so we want to use the same car, even though I think using this big one you could have seen better. But since I let you choose, we decided to use the blue car. Where we go? Here it is. All right, so we want to use the same car because remember, we're only investigating the speed of the car, how the steepness of the slope affects the speed of the car. Who can tell me what the steepness of the slope is? What part of the scientific method? Would that be the independent variable, the dependent variable, a control, or a constant? The steepness of the slope. What we're investigating, what we're just changing just now. We went from a steeper slope to a less steep slope. Yeah, Toby.
Like control?
Not the control group, no. Thank you, though, for trying. So the control group is what we're comparing, and we don't really have a control group in this particular experiment, but we are changing the slope, right? So this is something that is being changed. So it's one of the variables. Is it the independent or manipulated variable? We're changing it on purpose. That's what we're investigating. Or is it the dependent or responding variable, which is what changes as a result of what we do to the independent? Do you want to try again, Toby? Anybody? No? All right, guys. So the steepness of the slope is what we're investigating. That is your independent or manipulated variable. Anybody want to try the dependent variable or the responding variable? What's supposed to happen as a result of changing the steepness of the slope? Anybody? Bueller? I hear crickets. All right, so the dependent variable would be your speed of the car. Actually, more than the speed, it would be the acceleration. How much is the car speeding up or slowing down, dependent upon the slope. Okay, so now we're going to do our data, get our data again. Okay, so got our car, got our stopwatch, and ready, set, go. I don't think my reaction time was very good on that, actually. Maybe it was okay. So 0.96, all right? So where are we writing that? That is going on our data table 2. So on data table 2, remember our meter, we're still going 1 meter for all 3 trials, so you can fill in your ones here. And then the time in seconds. So our first trial was 0.96 seconds. All right, let's go with trial number 2. All right, so we've got top of the ramp. All right, ready, set, go. Kind of went off the ramp a little bit, but I got 0.79. All right, so let's get that in there. 0.79, and then let's do this one more time. Okay, all right, everyone, gears up, go. Oh, sorry, I have to do that again. I messed that one up. start. All right, ready, set, go. All right. 0.85. All right, so let's put that in there. Okay, so 0.85. All right, so then what you are going to do, just like you did in the previous data table, you're going to add up your times and divide by 3 for your average time. And here, you're going to calculate your speed for each of the 3 trials. So 1 divided by 0.96, distance divided by time. 1 divided by 0.79, that answer goes there. 1 divided by 0.85, that answer for speed goes there, meters per second. And then you're going to add those 3 speeds up and divide by 3 to find the average speed. Okay, so let's go ahead and make those calculations right now. So take out your calculator and let's work on those. Raise your hand when you have something for us. Can I assign? Maybe I could assign a couple there for you. Maybe that will help us a little bit. Trevor, would you mind calculating for us the average time? So add up the 3 times and divide by 3. Raise your hand when you've got it. Thank you. And then let's see. Nate, would you please get the speed for trial 1? All right, 1 divided by 0.96.
Yes.
You got that one already, okay?
So I got 1.04 m divided by s.
Okay, I'm sorry, 1.04? Okay, gotcha. Divided by s threw me off for a second there. Okay,
Yeah.
Phoebe, could you do the average, the speed for trial 2? 1 divided by 0.79. And then raise your hand when you've got it. And then let's see, I'm gonna get Toby. No, you already did 1. Let's see. How about Andrew? Andrew, I'm gonna have you get the speed for trial 3. Raise your hand when you have it. And then last one, Mason, I'm gonna have you, oh, you don't have a microphone. Actually, I'm gonna have Derek. Derek, would you then please calculate, just have it ready to go. You're gonna calculate my average speed. I should say just have your calculator ready to go. And I'll come to you last after we get all the speeds written down and I'll have you calculate for us the average speed. Okay, so raise your hand, guys, when you have the ones that I've asked for. All right, Trevor, what'd you do for your average time? Trevor? Did you hear Trevor? I unmuted you. Trevor. Have I lost some of you guys? Where are you? All right, some chat. All right, let's see what you got going on chat. Nothing. Oh, Trevor's mic isn't working. Okay, Trevor, you can type it for us, average time, and I'll relay it to the group. Okay, guys, since we are, can you raise your hand if you have the numbers that I've asked for? And Trevor, were you gonna, oh, Trevor wrote it down. Okay, 0.86. Yep, that makes sense. 0.86, that's our average time that it took for the car to go down those three. All right, who else has their, let's see. I think I asked Andrew. So Andrew, what'd you get for your speed for, I think it was trial 2?
No, you said for me for trial 3.
Okay, trial 3 then, thanks.
I got 1.17 and rounded it to 1.18.
1.18, okay. And then who did I assign number 2 to?
I think you assigned Nate.
Nate, yeah.
No, I did 1.
Then who did 2?
Oh, that's right. It was, I can't remember now. But who, was it Cade? Speak up. How about Asher? Asher, do this for me. Do your, I'm muting you here. Oh, Bryson's raising his hand. All right, we'll have Bryson do it since he's got it. All right, Bryson, I unmuted you there.
I was just saying it was Phoebe that was doing it.
Oh, yeah, that's right. It was Phoebe. I'm sorry. I thought I got something from her already. Okay, Phoebe, did you get your speed for trial 2 for us? No. All right. Going back to Asher. Asher, could you do this one for us, please? Yeah, 1 divided by 0.79. That's our
I got, divide, what?
yeah, speed for trial 2, 1 divided by 0.79.
I got 1.26.
1.26. Okay, that sounds reasonable. All right, now Derek, I asked you to calculate our average speed for us. So Derek, do you have a calculator handy?
I do.
All right, excellent. Can you please put in your calculator those 3 speeds, add them up, 1.04 plus 1.26 plus 1.18 equals, and then divide by 3 and give us that number.
1.16, I guess.
1.68?
No, 1.16.
1.16, 16, like that?
Yeah.
Okay, thank you. Yep, that looks reasonable. All right. Okay, guys, so now you've got those numbers in. There were a few more you had to do up here, so don't forget those. We will go to, I want to do our seatbelt saves lives next to make sure we've got enough time for that. And then looking at our time, we'll go back up and see if I can't help you with your acceleration. And we'll look at some of these questions together. Okay, so now what we're gonna do is we're gonna make a person out of clay or Play-Doh, and we're gonna put that person on top of the car, and then we're going to roll it down the hill, and we're gonna see what happens. So we are going to use, this time I am gonna use this car because it'll be easier to stick my clay person on the car. All right, so here is our honorary howler monkey in his purple and yellow, and I will put him on top of the car. So I'm gonna pretend that he is riding in the car here, and he's not wearing his seatbelt. Shame, shame on this howler monkey for not wearing his seatbelt. Okay, so he is going to travel down the ramp, and when he hits the book at the end of the ramp, we're going to watch and see what happens to the car and also what happens to our person. Oh, I just thought it was, no, it's okay. All right, okay, so we are going to be observing these 2 objects as they go down and hit the book at the bottom. All right, here we go. Oh, he's already fallen off. Stay on, buddy. Hope I gave you guys enough time to put your person together. Is anybody actually doing this at home? Nobody had responded when I'd asked that question, and I haven't seen anybody's video. Raise your hand if anybody is actually doing this alongside with me today. Anybody? Anybody? No takers? Oh, Bryson is? Bryson, did you just forget to put your hand down from before, or are you actually doing this with me? I'll unmute you.
No, sorry.
No, you're not
I
doing
put
it.
my hand up from before.
All right, no problem. But I'm going to do another one on Thursday, and we're going to do magic tricks on Thursday. So hopefully you can join me for the great Tankini and pennies from heaven. All right, here we go. All right, so you saw that the car hit the book, bounced back. The person came flying off and hit the book somewhere over there. All right, so tell me what happened to, so let me start this way. So according to Newton's first law, remember, an object in motion wants to stay in motion, and it wants to stay in motion at the same speed, in the same direction as it was before. And the only way it's going to change what it's doing is if an unbalanced force acts on it. So why did the car, when it hit the books, bounce backwards? So basically it changed its velocity because it went in the opposite direction. Remember, velocity is speed and direction. So it actually changed direction. So obviously an unbalanced force acted on it in order for it to do that. What was the unbalanced force? Who's got this? What was the unbalanced force that acted on the car to make it change its direction and bounce back? All right, Trevor.
It's acceleration.
Why did its acceleration change? What was the force that made the acceleration change?
The gravity.
No.
Not the gravity. I know what you mean.
The gravity did make the car accelerate going down the ramp. That was the unbalanced force that made it speed up. That's another question I was going to ask you. But what stopped it?
Inertia.
Inertia is an object's resistance to change. So its inertia kept it going, and
It's
kept the plane moving at the same speed and direction as the car. So they both have inertia. But what made the inertia, what made the speed change at the bottom?
The momentum. I think, I'm not sure. I'm not sure.
Momentum is a force of a moving object. So the car didn't have momentum when it struck the book. And when it struck the book with its momentum, its force, it put a force on the book, right? But the book, according to Newton's third law, the book put an equal force back on the car, but in the opposite direction. And because the book had more mass than the car actually moved backwards in the direction of the book's pushing, not the direction of the car. But they pushed on each other with equal force. So that's Newton's third law. But what I'm looking for here is that it was the force of the book that caused the car to change its direction, because when it hit the book, that book stopped it from continuing its motion in the direction and the speed it was before. So there was an unbalanced force that acted on the car, but was there an unbalanced force that acted on the clay person? So why did the clay person keep moving after the car stopped? Anyone? Why do you think that happened? Why did the clay person keep going in motion? So was the clay person in motion with the car in the same direction and the same speed as the car? Yes, Miss Hughes, it was. And so when the unbalanced force acted on the car to make the car stop moving, or to actually reverse it a little bit, no unbalanced force acted on the clay person, at least initially, not until it hit the book. And when it hit the book, then it was the unbalanced force that made the person stop. So when you're wearing a seatbelt, the seatbelt holds you to the car. So you are staying with the same motion as the car. So when the car stops, you also stop. Without the seatbelt, you keep on going, maybe out the front windshield, and that would be bad. All right, so going back to looking at our lab report here that you're going to be turning in on Friday. So we just did here the seatbelt save lives. And you have some questions here that you have to answer. So we've just got a couple more minutes. So I'm not going to do all these questions with you, but we do need to look at our acceleration here. So we need to actually come up with these couple numbers right here in data table 1 in order to do our acceleration. So let's take a look at that. So 1 divided by 0.90 is going to give us our speed for trial 2. So guys, do this with me. Get the practice with it because it's important for you to practice since you're not really liking answering the questions for me, you know, in front of class. Some of you are, and thank you so much for doing that. But please do this so that you get the practice in. So we just did 1 divided by 0.90. And I got 1.11. Repeating, but I'm not going to put a whole bunch of ones in there. Okay, we're just going to go to the hundreds place because that is where all of our numbers are. So we're going to stay with our least significant number of digits. Okay, so for trial 3, we're going to do 1 divided by 0.69. And we get 1.45. All right, so those are our 3 speeds for the steeper slope. And to get the average speed, so it'll be easier to compare data table 1 with data table 2, let's add them up. So we got 1.37 plus 1.11 plus 1.45 divided by 3 is 1.31. Okay, so that is your average speed for the steeper slopes compared to this average speed for the less steep slope. Which slope gave the greater speed? I will not answer this question for you. You answer it for us. So which one of these numbers is the bigger speed? The steeper slope, 1.31, or the lesser steep slope, 1.16, half as steep? Raise your hand. Nobody's got it. All right. Well, I guess you'll have to compare that yourself when you're answering your questions, but I'm pretty sure you got that. Okay, we're about out of time, so let me just show you how you fill in your acceleration. So you're going to take your speed of the car on the steeper slope. That was your 1.31. All right, so that's your 1.31. And your speed of the car on the less steep slope, that's your 1.16. 1.16. All right, then you're going to subtract those two. You're going to subtract 2 minus 1. You're going to subtract these here. Here, you're going to get the change in time. So you're going to take your average time of car 1 minus the average time of car 2. Well, here's your average time of car 1. Here's your average time of car 2. All right? So it tells you what to do right here. And then you're going to calculate your acceleration. Remember, acceleration is your change in speed between the two different sloped ramps, which is what we were investigating today. So you're going to take your number 3 divided by your number 4. So your number here for 3 divided by your number here for 4. And that's going to be your answer to your acceleration or change in speed between your two slopes. And then you'll be able to answer the questions. There is one question at least about that. And then there's some other questions here about the Newton's law. So see here, it's questions asking about how it changed speeds, etc. Okay, I am out of time. Got to get to my next class. So sorry I didn't have time for questions here, but you guys have been pretty quiet anyway. Come see me during my office hours today if you need some help with this. And I will have this on YouTube in an hour or so. All right, actually it might be an hour and a half, but yeah. All right, have a great day, everybody. Thanks for joining me in today's Hot Wheels Lab. Bye now.